Alright, good day, I'm Mr. Simons and welcome to Grade 12 Calculus. So here in this lesson, we're just introducing to calculus and the first principle. Right, so calculus in short consists out of two components, normally the study of change, which is differentiation, and area integration, which you study at university or those of you doing AP Maths. Right, it's one of the most powerful tools in maths and is primarily used to study change between one variable in relation to another variable. To give you an idea, the bigger my car engine is, how much petrol would it consume? On the stock market, what happens when the banks come in, what changes would take place, etc. In engineering principles, vertical projectile, if I apply a force of this, what to transpire, etc. Right, so in short, differential calculus, which we're going to focus on, revolves around rate of change, and rate of change is simply called a gradient of a graph, or it's equivalent to that. Right, so if you look at the linear function and rate of change, here we have a function of y equal 3x plus 6 to the points 2 and 12, 0 and 6, so negative 1 and 3, and negative 2 and 0. So I calculate the gradient between 0 and 6 and minus 1 and 3. There, 6 minus 3, 0 minus minus 1, 6 minus 3 is 3. 3 divided by 1 gives me a gradient of 3. If I look at the gradient between 6 and 0 and minus 2 and 0, so y2 minus y1, x2 minus x1, 6 minus 0, 0 minus minus 2, so that gives me 6 divided by 2 is 3. So you see, for a straight line there, my rate of change is constant because the gradient stays constant. No matter where I calculate, I will constantly get a gradient of 3. So this is equivalent to driving at the same speed, 120 kilometers per hour. You are staying constant. Yeah. It's like we say in physics, constant velocity, zero acceleration. Alright, now if you look at the quadratic function or parabola, you can see it's constantly changing, it's curved. Right? So there my gradient is constantly changing. Because it's constantly changing, we should then be able to get what we call an average gradient between 2 points and the gradient of a tangent, which generally is a line that touches the graph only in one place. Alright, that's referred to as a tangent. So for average gradient, we're still going to have change in y over change in x. This can be written now as fx plus h minus f of x divided by h. So in short, when I subtract the two x values, I'll have a constant, and that is just so that we see there's two different y values at two different points. So I would have fx plus h here and fx there, or fx plus h there and fx there. So fx plus h is the bigger one of the two. Right, so let's look at it. So for average gradient, look at the gradient between 4 and 7. Right, then I'm going to look at the gradient between 3 and 0. But all I've done here is I've drawn constant gradients between 2 points on the parabola to see what transpires. So if I take the average gradient between 4 and 7 and 0 and negative 9, to get 7 I would write it as f of 4, and to get negative 9 I can write it as f of 0, meaning substitute 4 or 0 in the equation, I would get 7 and negative 9. So therefore minus 0, that there on the top becomes 7 minus minus 9, which gives me 16. 4 minus 0, which is 4. You see my h value, 4, so 16 divided by 4 gives me a gradient of 4. If I come a little bit closer, so as I move h from there to 3 and 0, what happens to my gradient? f3 minus f0, 3 minus 0. Right, so that gives me 0 minus minus 9, which gives me 9 divided by 3, which is 3. Right, so as you can see, as I move from this point towards there, my gradient is becoming smaller and smaller and smaller till eventually it tends to 0. So we say notice point 4 and 7 shifts closer to 0 and negative 9, the gradient tends to 0. So as f of x plus h shift towards fx, gradient tends to 0, and we have a specific way to write this. Right, so it's called a gradient of a tangent. So as I've taken all those gradients, eventually it's going to come to a point where it just touches the graph at one place. So the gradient of a tangent to a curve is gradients of various lines as they get closer to that point. So therefore, gradient at point 0 and 9 is approximately fx plus h minus fx divided by h. So the process of getting h closer to 0 is known as taking the limit. So gradient at point 0 and 9 equal the limit as that h tends to 0 of fx plus h minus fx divided by h. This is referred to as my first principle equation. So in exam, when we ask find the first derivative using first principle, we're going to write first derivative, meaning f prime x equal limit h tends to 0, fx plus h minus fx divided by h. So h represents any counting values, and note it's x plus h minus x. X and x cancel, and I'm left with h. My two y coordinates, the bigger one, fx plus h, minus the smaller one, fx. Limit h tends to 0 simply means as I move my x value closer to 0, what happens to my y value? So you see there's my value of h, x plus h minus x, they are distance h apart. And there's my two y values, fx plus h minus fx, top minus bottom. Alright, but we will explain some limits so you get this concept of limiting something to a point better in the next lesson. Hope you enjoyed the lesson. Please subscribe. Wish you nothing but the best. Bye.